Okay, this is the last thing on the first exam. Less than 10, roughly about 10 lessons and then an exam. 10.3 is a section from the textbook, and it is on what's called higher roots. An expansion of our last lesson where we focused on square roots and reducing them. All of those things you can actually, and rationalize your denominator, and all of those things apply to higher roots, but we do not have time, and it's not part of our curriculum to do all of it. But we want to get a feel for the basics of it, and specifically what are called rational exponents. So let's go. Higher roots. And we're going to talk about, we did square roots, there's going to be cube roots, so a number that when you cube it, it's going to be fourth roots, fifth roots, and generically I'm just going to call it the nth root. The nth root of a number n, so I can use n. What did I use, a? Yeah. Is another number r. It'll be clearer once we get to an actual example with numbers. Such that, and our definition for square root was we were looking for a number that when you square it you get back the number, but here we got to raise it to the nth power for the nth root, and we get back a. Okay, denoted by the radical symbol with an n in the little nook, and the term for that is the index. So if it's a cube root, that index will be 3. If it's a fourth root, that index will be 4. A is still called the radicand. I've been using that term a lot since I introduced it, and it still applies. Radicand for the number under the radical. Square roots are essentially second roots because that power there will be a square or its second power. Which we've been referring to it, or we learned this term. Third roots are called cube roots, or you can call them third roots, that's fine, either one. But anything beyond that, you got to actually use a number. There's no shorthand for calling a fourth root. You just got to call it a fourth root, fifth root, sixth root. It can go infinitely up, but I think the highest I do is like the seventh root, and it's a very specific thing. But most of the time I go up to fifth roots. Third roots are called cube roots, because for that one, you're looking for a number that when you cube it, you get back the original a. Okay. We're going to find all cube roots of the following. We'll do one at a time. We'll do 8. I'm going to use that arrow. Again, it's not equal to that cube root. It's just I'm working something out and I'm getting an answer that's not equal to my original 8. Specifically, I'm looking for a number that when I cube that number, I get back 8. Think about it. Think about if there's any others. I should probably mention now that we need to be somewhat familiar with certain powers. Which I'll do later. Okay, so 2 works. So 2. And then the last time we did square roots, how do you think? Is there another one that works? And negative 2 would have worked for square roots. Does negative 2 work here? Don't put a comma there because it's not going to work. Negative 2 cubed, because it's negative 2 times negative 2 times negative 2 gives you a negative 8. That does not give you 8. Negative 2 is not a cube root of positive 8. So no, that's it. Only the one. Negative 2 does not work. You can write that in. Negative 2 does not work. You do not get plus or minus for cube roots. Next, a separate problem. find all cube roots of negative 8. Now when it was square roots, we made a negative, it was none, because no number squared would give you a negative number. Here, it's different. There is something that works. We're looking for something that when you cube it, you get negative 8. 2 does not work, but negative 2 does. And negative in there will carry over. Negative 2 times negative 2 times negative 2 is 3 negatives. You'll get a negative 8. So that means negative 2 is the cube root of negative 8. So for cube roots, a positive number will have a positive cube root, a single one, not plus or minus. A negative will have a single negative cube root. One more, just to make sure we understand it. Go ahead and do negative 27. All cube roots of negative 27. Yeah. Let's spray. Okay. You don't have to write out this whole thing that I'm writing out every time. What cube gives me negative 27? If you know what it is, and hopefully you get familiar with it, you can just get your answer. But here I'm just making sure we're mentally going through what cube gives us negative 27. Negative 3 works. Again, it's not your negative 27 is not equal to negative 3. I'm putting an arrow to indicate that I have mentally gone through some process to get an answer that is the cube root of negative 27. Here we're going to find all fourth roots of the following. Think about what we're doing here. A number that when you raise it to the 4th power, you get back 16. Again, you don't have to ever write this out, but it's helpful sometimes to think about it. We're going to give it to larger numbers, higher roots, and this process can be helpful. You have to know your powers, and 2 to the 4th is 16. 2 times 2 times 2 times 2 will give you 16. So 2 works. Is that the only thing that works? Well, I do want you to think about that negative. Does the negative work here? Negative does work. Because now you don't have to write it out, but negative 2 times negative 2 times negative 2 times negative 2. The negatives will all cancel out because there's an even number of them, because it's 4th. It'll cancel out, give you a positive 16. So negative 2 does work. Plus or minus 2 in this case. Like the square roots, we do get plus or minus there. $81. Think about that. I'm going to start writing on something while you think about that, but well, let's see which way I'm going to go. Okay, so 3 works. And if you didn't know that, it's something that you might need to be familiar with. So I'm going to talk about different powers that we need to be familiar with. But anyway, 3 to the 4th, that's 3 times 3, which is 9, times 3, which is 27, times 3, which is 81. That does give you 81. What about negative 3? Yeah, for the same reason. Negative 3, 4 of them will cancel out, give me a positive 81. Yeah, plus or minus 3. One more. Go ahead and do all 4th roots of negative 16. Okay, so what raised to the fourth power will give me negative 16. 2 does not work. 2 will give me positive 16. Negative 2 will not work to a fourth power because that'll cancel out all the negatives and still give me a positive 16. Nothing works here for the same reason as square roots. No number to the fourth power is going to give me a negative number. Not a positive, not a negative. The negatives will always cancel out. I will not get a negative out of it. This one is none. There are no fourth roots of a negative number. And the distinction between what we're talking about over there versus here is fourth roots or cube roots. And fourth roots behaves like square roots, and the difference is even or odd roots. So we're going to talk about that. But before we do, we're going to talk about the distinction between even or odd roots. Let's go through this. In theory, I could give you big numbers and crazy things, but just to make sure you understand the concept, I keep it small so you can focus on just making sure you understand the concept of the root. But it does require you to be familiar somewhat with powers. So when you're dealing with square roots or squares, you got to know your multiplication table version of it. 1 squared is 1, 2 squared is 4, 3 squared is 9, dot, dot, dot. I'm not going to write them all. 8 squared is 64. Make a note of that. Dot, dot, dot. And 12 squared is 144. And I won't expect you to know anything beyond that. 13, 14 is not on the typical multiplication table, so we'll stick with that. But cubes, when you deal with these cube root ones, we had 27, 8. There's several cubes you need to be familiar with that I'll be asking questions regarding cube roots for, where the answer will be 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. I usually go up to 4 cubed and throw 64s at you in cube root problems. 5 cubed, I think, comes up once or twice on the homework, which is 125. Anything beyond that, 6 cubed, you don't need to know. 7 cubed, I don't even know myself. 8 cubed, who knows? But we have fourth roots here. One to the fourth is 1. So notice 1 can be a problem that's involved in any of these square roots, cube roots, fourth roots. 16 is 2 to the fourth. That's why I can ask you about 16 in those fourth root problems. 3 to the fourth is 81. And 4 to the fourth, I don't know off the top of my head, so you're not responsible for it. But make sure you recognize 16, that's 2 to the fourth. 81 is 3 to the fourth, and then that's the only fourth root problems I'll ask you. 1, 16, or 81 you have to recognize. You will have a couple fifth root problems. Basically, when I do ask you it, it's either going to be a 1 or you're going to see a 32, and you just have to recognize 32. It may not be recognized 1 now as such, but 2 to the fifth is 32. I'm not going to ask you about sixth roots or seventh roots, at least not ones where you have to recognize the number right away. So anyway, that's the powers that I expect you to recognize, because I'll throw them at you. They are just powers of some small numbers, and yeah, so basically be familiar with that. And let me point out one thing on this list. Notice that 64 is 8 squared, so I can have a square root problem involving 64. But also notice that 64 is also 4 cubed, so I can ask you cube root problems and have you deal with 64. So 64 can come up in both contexts, a square root problem or a cube root problem. Oh, 16 also can be here, a fourth root problem or a square root, but I didn't write it. So just be, sometimes you got to be conscious of what power you're dealing with. And let's do the even and odd. I'm going to erase this. Let's summarize some things we know that we've kind of learned about even roots, and then we'll do some odd roots. For even roots, positive numbers have 2. And they're going to be the plus or minus, like the plus or minus 2 for our fourth roots of 16. Negatives have none. And when you see that radical symbol with an n in there and it's an even number, this symbol represents only the positive root. Because there is plus or minus a lot of times, unlike square roots, this radical symbol represents the positive root only. Okay, and so those are the behavior of square roots that we talked about last time, but they actually apply to any even root, like square roots, fourth roots, sixth roots if I ask you, which I won't, eighth roots in theory, but I'm not going to ask you that. I do want to mention, I'll mention it after. Odd roots, like a cube root or a fifth root, which will come up occasionally, but mostly cube roots will be the one you're dealing with. Every number has exactly 1. You can have a cube root of a negative number. You can have a fifth root of a negative number. It'll have exactly 1, not plus or minus. Because there's only one, that symbol, the radical symbol with an odd index, an odd number in that milk, represents the only root, whether it's positive or negative. So this could, for odd roots, this could be a negative. And another thing is, if you do have a negative under there, which is allowed for odd roots, it's not going to be allowed for even roots, but it is allowed for odd. We'll see some examples, but you can pull that negative out. And just focus on doing the nth root of that a, if n is odd. So this will apply to fourth roots, and it'll look like that, with 4 as your index. It would apply to sixth roots, but I won't give you those. And I want to mention here, a square root is essentially a second root. And in fact, the iPhone calculator had a button with that symbol. They did put a 2 there to distinguish it, because they also had a 3, a cube root button on the iPhone calculator. I think that's it. But so to distinguish it and make sure you know which radical they're using, they put a 2 in their little button there. But I'm going to mention, they usually don't. Usually a radical symbol without an index specified is assumed to be a square root. So when you see that without an index, it's assumed to be a square root. It's like a 2 in there because you're talking about squaring things, but they usually won't write it. So be conscious of that. All right, I'm going to pause here, and then we're going to simplify expressions with these radical symbols, which will involve us doing the same thing we were doing earlier, which is thinking about what to the third power gives us 8 or whatever. I'm going to pause it though. So. Alright, let's simplify. You're not going to be doing anything as extensive as the last one where you're going to pull stuff at the radical and worry about all those criteria. This generally will be a single answer that you can pop off right away as long as you're familiar with the powers. You did keep them. Maybe I want to have them up here, but... And I guess you have notes for your exam, so you could have this list if you wanted to. Let's see. Okay, we'll go one by one. Cube root of, that's read as the cube root of 64. What number cube gives you 64? Again, you don't have to write that. That's our thought process, but as long as we can do that mentally and figure out what number goes in there to make it work. And thinking about your powers of 3, so you're going to just imagine this column and remember that you got 1, 8, 27, 64 is there, and 125 are things that are perfect cubes. That's a 1. 4 works. Again, and this one is equal. So this is saying the cube root of 64 is equal to, and that's 4. So that is an equal. We are simplifying a radical involving a higher root. Now the last time I said kind of a negative in a radical, but I was technically lying because you can, depending if it's an even or odd root. So you can't have a negative inside a square root. You actually can't have it in any even root, but odd roots are fine. This is a legal expression. It's a real number. It has an answer. It's related to the answer above. It's related to us getting a 64 from a cube, but the negative there means, I mentioned a property is you can pull that negative out. You don't have to, I mean, but you pull that negative out and just, of an odd root, and then just work on the cube root of 64 and figure out what that is, and tackle the negative afterwards. Basically, it's going to be the negative of that, negative 4. Negative 4 does work, because it'll be negative 4 times negative 4 times negative 4. The negative will carry over to your answer, so this is equal to negative 4. Here I'm going to have you do the fourth root. Fourth root's I got to keep it within this small list. So you'll see a lot of 16s in fourth root problems. Sometimes in 81, but nothing higher than that. But the main thing I want you to be able to handle if it's a fourth root of 16 and if it's a fourth root of negative 16 and what are the rules for evens or odd roots. And even if you don't memorize the rules, you're kind of thinking, can you raise something to the fourth power to get 16? And then for this one, can you raise something to the fourth power to get negative 16? Will that work? We'll start. Pause it if you want more time to think about it. But the 16 should be pretty straightforward because that's, where is it? Right there. You think about this whole list of fourth powers. It's a short list. Like I said, I'm not going to make you remember anything beyond 3 to the fourth, but 2 to the fourth is on there. It's going to come up a lot. So 2 to the fourth gives me 16, and therefore the fourth root of 16 is 2. We did one earlier, and we did note that there are 2 fourth roots of 16, negative 2 and positive 2, but remember that this symbol only represents a positive for those even roots. What works here? Not 2, not negative 2. Negative 2 does not give me that because it's going to be positive 16. That's not true. Nothing works. Nothing to the fourth power is ever going to give you a negative. This negative cannot be pulled out. In fact, this one you have to recognize as not a real number. And let's look at this. Negative under an odd root is legal and will give you an answer. It does. Negatives do have odd roots, cubits in particular. Negatives under an even root is not allowed. That's not a real number, like a square root. What else I got? All right, one more. Just making sure it'll come up in some of the later problems as well, so I gotta make sure we are okay with recognizing 32 as some power of 5. I did put them in the list. You're thinking about the fifth powers that I wrote on over there, right there, so that's relevant. The negative is relevant as well. Think about whether that's allowed. Can you have a negative of a fifth root of a negative number? You can also think, will something to the fifth power give us negative 32? Based on that list, 2 to the fifth gives me 32. Does negative 2 to the fifth give me negative 32? Yep. Odd root. It will have a fifth root. I could pull that negative out of an odd root if I wanted to, or I could just recognize that negative 2 works. Doesn't matter, I don't need to actually do that. I can just say, yeah, I know that negative 2 is going to work because it's going to be 5 negatives. And when I do the fifth power of those, I will still have a negative. So it will give me the negative 32. Perfect. All right. Should I pause? How complicated are these problems? I'm going to pause. Okay, on your exponent sheet from 2 lessons ago, lesson 8, it had extra stuff. Well, I don't say extra stuff, but it had things we did not cover at that stage, and I mentioned it. They were rational exponents, and now that we know the term rational, it makes more sense. Rational numbers being numbers that can be written as fractions, and these are basically fraction exponents. A to the 1 over n power. That 1 over n is just the nth root of a if it exists. It might be one of those where it doesn't exist, but I usually don't throw that at you for this particular type of problem. Just want to make sure you can interpret that as that 1 over n power as a root, and then do what we just did. But it doesn't always have to have a 1 on top of that fraction. It can be a to the m over n, which, in case you're wondering where it comes from, you don't have to write this down. We could separate it out as, we could use one of those rules in reverse where we split it up as 1 over n power to the m, but either way, it's going to be thought of as the nth root of a, all of that raised to the m power. So you have the row in front of you. You don't need to know how it's derived, but that's the derivation of it. It's the m that's on top ends up being a power on the outside. The n that's on the bottom ends up being the index. So it's the nth root of a, but that raised to the m power. And we're just going to do that. Make sure you know which number goes where. The n becomes the index, the bottom number rather, the top number m will become the power on the outside when we apply this. Okay, then let's apply this. We'll start off somewhat simple, although there's a little bit tricky in this in that it's a 2 on the bottom. So this is 36 to the 1/2 power. That's 1 over n. You have to recognize fraction powers, you're going to apply one of these, but if it's 1 on top, it's just this. So that 2 goes in the nook, and your base becomes the radicand. So it's the second root of 36. And the second root is what we know as the square root. And actually, we don't even write that in usually. You can, but most of the time when they work it out or they give you a square root, they just omit the index. But it is, if it's empty, it's implied to be a square root. And this 2 means we're doing a square root. What does that equal to? 6. Perfect. So 1/2 power is a square root. We're going to do 8 to the 1/3. Still 1 over n. So we're going to apply that first rule. A radical. The index is 3. 8's inside. Be careful when you write it this way. When people are writing messy on paper, very small, sometimes they'll write the 3 like that. But that looks like it's a 3 on the outside, like a whole number 3 times a square root of 8. Make sure you put the index in the nook small and make sure it's clear that it's not a 3 on the outside of a square root, but that it is a third root of whatever. So it's got to be small and in the nook for it to be readable and not misinterpreted. And then once you have that, then it's like the problem we did earlier. What number, when you cube it, gives you 8? What's the cube root of 8? 2. Perfect. Alright, what do we got here? 16 to the 3/4. It's not 1 over something. We're going to have to do the m over n one. Just go about it slowly. You're going to have a radical, but it's going to have an index. And then you're going to have a power on the outside. And the base becomes a radicand regardless, so it's for sure going to be some kind of root of 16 raised to some other power. And just make sure you read this carefully and make sure you know where the 3 and the 4 are going. The bottom number is your index, so this is a 4th root of 16. The top number becomes the power on the outside, which is a cubed. And once you write it that way, it's just a matter of simplifying. These are all designed to be fairly nice. Or just actually, just nice, because the 4th root of 16 has a nice number, and you're going to find that number, raise it to the 3rd power afterwards. So just simplify that 4th root of 16, that's 2. You're raising that 2 to the 3rd power, and you actually do that now, 8. 16 to the 3/4 power is equal to 8. All right. No, it's not, yeah, you have it in front of you, hopefully. Grab that exponent sheet or have that in front of you, because I don't know why I erased it. I should have left it up. But let's keep plowing along and, okay. This is just something to the 1/3 power, just like that one. Your base is negative, but that may or may not matter depending what type of root it is, but let's just rewrite it as a root first, and then we'll decide if it's not a real number situation or if you can do it. The 3 goes in the nook, negative h your radicand. There is no, I mean, If you interpret it as the m over n, it's going to be the 1 power, and which is not going to do anything anyway. That's why they just have that as a separate rule where you just don't bother with anything else other than doing the radical. Is that a number? Is there an answer, or is that not a real number? It's an odd root. And there is a number that works, -2. So -8 to the 1/3 power gives you -2. All right, get ready for this. 27 to the -2/3 power. Now, I'm gonna actually write something over here. We're gonna have to use some old rules combined. I'll just write them as I go. So you have your exponent sheet. Ooh, and on the bottom, towards the bottom, you have the a to the m over n, which we just discussed. But here we have a negative exponent, and that's something we handled in chapter 8, not chapter 8, but notes 8. Negative power, we will generally rewrite it, 1 over a to the n. So I'm going to apply that first. I'm going to do this in steps. There's two things going on here that are a little bit stressful for us. You have a fraction exponent, which we're just learning how to handle. We have a negative exponent, which is something we have handled in the past, but two things going on at once with that exponent, but let's just handle one at a time. With the negative, I encourage you to just rewrite it as a positive, but on the bottom, I'm going to do that. I'm going to recap what it means, or how we go through it. 1 on top according to that. The base goes down as is. 27 is my base. The exponent, -n, we rewrite it as a positive and on the bottom. That -2/3 power becomes +2/3. We're not done. We still have to now have to work out 27 to the 2/3. It is a nice number. We'll work it out. Okay, and so we're going to write that as a radical using that. 27 is obviously my radicand, but let's make sure I put the numerator and denominator in the right place. 3 is my index because that's a bottom number. It's a 3rd root of 27, which is a nice value. The m on the outside is 2. And here, pay attention because people keep doing this and I need to make sure we understand this. People want to just focus on that, and that's good, you want to focus on that, but then they're going to forget that that's on the bottom and there's a 1 on top the whole way. And it's fine if you just put it on the end, our answer is going to be 1 over something. As long as you remember at the end, it's good, it's fine, but it's not fine if you forget, and it's better if you just always bring that 1 down, even though we're not going to do anything with it. I'm going to take several steps to get to our final answer, but every step of the way I'm going to put 1 on top over the thing that I'm working on, so I don't forget. Alright, 1 on top, start working on this. Cube root of 27, all I'm doing is the cube root of 27. I'll square it afterwards, and I erased my whole list, but yeah, I know what it is, it's 3. Then I do 3 squared, but it's on the bottom, so I'm going to again write 1 on top, and then 9 on the bottom, and I'm done. That's my actual answer. Negative exponents, handle that being that rule. Then do the fraction thing, and don't forget it's on the bottom of that stage, and every step of the way you should write 1 over it, so that you don't lose track of that at the end. And don't give me 9 as an answer. 9 is wrong. It's 1 over 9. Okay. Think about that one. Pause here. Be very careful. This also has a lot going on. Different things going on. Be methodical about it. It's a negative exponent. It's a fraction exponent. It's a negative base too. -64. Unlike this one. The base is negative. It's still doable. But make sure you know when you're applying the rules, what's changing from negative to positive, what's staying as is, or remind you that when you should probably do it the same way. Take care of the negative first, And when you do that, the base goes down as is. You keep the base as is, but move it to the bottom, and you change the exponent from negative to positive. After that, you'll have a fraction that's just 1 over n, not m over n, so you can just do that. You won't need the m part of it because it's going to be a 1 over 3 after you rewrite it. Pause here, take some time to do it, and unpause, and I'm going to start right now. But again, I'm going to take care of the negative. I'm going to rewrite my negative exponent as positive. It'll end up on the bottom, but I'm going to be very careful. My base goes down to, put 1 on top. My base goes down to the bottom as is. Negative 64 is my base. I move that base to the bottom. It does not change signs. It's still a negative 64 base. My exponent changes from negative to positive, so that negative 1/3 exponent becomes a positive 1/3. And now I'm just simplifying that bottom. 1 over. I'm going to rewrite it as a radical because I'm more used to interpreting it that way. And so it's going to be 1/3 power is going to be a cube root. The base there is now my radicand. So it's a cube root of negative 64, but on the bottom of a fraction. And I'm almost done. Cube root of negative 64 is a legal, because it's an odd root of a negative, which is a thing. You can have odd roots of negative numbers. It's negative 4. You can leave it like that, or you can pull a negative out front of the stage, or it doesn't matter. But notice how careful I was about what's changing signs and doing just step by step and take care of the negative first. There's other ways to do it. You could do it in a different order, but that's the way I'm going to encourage you. Take care of the negative first, make it a positive exponent, and then handle the fraction. Okay, all these came out to nice numbers. And that's going to be true for the entire homework set. All nice numbers. Not going to throw crazy stuff at you. However, let me mention, you're going to see things that look kind of crazy. Hold on. Yeah, okay. But they're not really, as long as you know how you're simplifying it. So these are the last page of the homework. Pay attention here. If all the rest was pretty smooth for you, pay attention here. Because people do get tripped up because they do want to just go straight to the m over n thing. And these problems are designed where that's going to go astray and go crazy and not turn out nice. If you start to try to apply that, you're not going to do that. So if I did, this is going to be not working out. I'd have the 4th root of 5 cubed times the 4th root of 5 to the 5th. And the 4th root of 5 is not a nice number. It's not on the list. It's not something we can do really, and it's not what I'm intending you to do. So you try that and it doesn't go anywhere and it's not working out nice, but I assure you this is going to be a nice round number answer. So what I want you to be able to do is utilize your other rules for exponents. We've been using the negative rule, but there is also a rule way up here, the product rule, where if you have the same base to 2 different powers, you can combine them into a single exponential expression with that same base by adding those exponents. So that's something that could be applied here, and we're going to apply it. And when you do those old rules first, it works out nicer. Let me do that. All right, I got to add exponents. Don't panic because they're fractions. Nothing different. All of the rules, m plus n, that kind of thing, do apply to any numbers, including fractions. So I'm going to add those exponents. I need a common denominator to add. I can't cross-cancel, but I do need a common denominator. Fortunately, it's already written over 4. I'm just going to add across the top and get 8 over 4. It's still pretty weird for me to try to do the m over n, but I shouldn't do that. I should reduce the 8 over 4. 8 over 4 reduces to 2. I don't even have to worry about the radicals because it's not a radical. It's just 5 squared. This whole thing just came out to just 5 squared or 25. But it required you to, even though they're fractions, resist the urge to go straight to that and try to see what you can do with these other rules first. So that last page of the homework, you're going to be utilizing your other rules to get it to be much cleaner. And a lot of those, at the end, you don't even get a fraction exponent to deal with. You don't deal with radicals. The emphasis here is those old rules will apply to fractions as well. Last one and we're done. think about the same thing I just said. You may not want to apply the m over n, the fraction rules right away. This one you definitely don't want to, because 27 does not have a nice 6th root, and we don't even really deal with 6 roots. That's a square root of 27, which 27 doesn't have a nice square root. But you do have the same base there and there, and you can combine them, and I got barely enough room to actually write it, but you have a whole list of rules. And right there, one of them is the quotient rule. The same base on top and bottom, you can combine them doing top exponent minus bottom. Go ahead and see if you can apply that. I want you to pause, apply that first. Don't apply those and get 6 roots of 27, so it won't work out. Note that you have the same base there and there, and you can combine those exponents by subtracting. It's just fractions, you're just going to be subtracting fractions in that case. No big deal, you can do it. You got to remember if you need a common denominator or not for subtracting fractions. You do. They don't have a common denominator right away, so you're going to have to rewrite them with a common denominator. It's going to take a lot of work. It's just actually mostly fraction type work. Reduce it. See what your exponent is. This one's not going to be as nice as that one, but it's a lot of steps here, but each of them you can do, you've done in the past. We're combining a lot of different things here, but just take it one at a time. The first thing is combining these. It's top exponent minus bottom. That's negative 1/2 minus 1/6. I'm going to simplify that exponent by doing fraction subtraction. Do I need a common denominator? I do. Between the 2 and the 6, the common denominator is 3. I'm going to write my base, but I'm still not going to deal with the 27. I'm just still working out that exponent. That's going to be negative 3 over 6 minus 1 over 6. When I combine that, that's a negative 3 minus 1. I do have a lot of people ask me questions about that, and they lost track of the negative when they did that. It's all cluttered up now, but that's a negative there. That's a minus there. And now that I have common denominator, it's essentially negative 3 minus 1 over 6. That's what we're trying to do. And that's just the exponent. So, like I said, a lot of work on this one. But step by step, remember, just doing fraction stuff. Negative 3 minus 1 is negative 4. Definitely reduce it. It's still not going to work out with the 6th root of 27 if you apply the m over n. I don't want you to. I want you to always reduce your fractions. 4 over 6 reduces to negative 2/3. I'm just going to pull the negative out from that top and make it in front of that. And now I've got a problem that's similar, not 24. And now it's looking like a problem that I maybe did earlier, or similar to it at least. But anyway, now we've got it down to just a negative fraction exponent. I still do have a lot of work to do, but this is going to work out nicely. So we're almost there. From there, if you got stuck and you didn't know what to do, at this stage, see if you can do it, because this is the main part of this lecture. Negative exponent. Base goes down. Exponent changes from positive to negative. Fraction exponent, it's already reduced, so this is the best I can do for reducing that fraction, and now I've got to do, my only choice is to try and apply that m over n exponent rule. 27 is my radicand. The 2 and the 3 is going to go in different places. Remember where they go. The 3 is the index. The 2 is the power on the outside. And now it should be fairly straightforward. Cube root of 27 is 3. I'm going to square that 3 because it's that 2 right there, and I get 1/9. So a lot of the different rules for exponents that I used here. I use the quotient rule for this one. I use the product rule for the other one to just combine expressions with the same base but different exponents. They were fractions, so I had to use common denominators to add or subtract. And then once I did that, I sometimes had a negative to deal with, but at the end, oftentimes I'll get a fraction. And you want to make sure it's reduced, because if you reduce it, it'll work out nicely. But if you try to work with 4 over 6, it's not. So that last page is a little bit tricky, but they're like this. You're using old rules for exponents first, and then the m over n rule if necessary. Okay, and that's the last thing that's going to be on this exam. At this point, you have 3 practice exams. After you do your homework and the quiz related to this, you have 3 versions of the practice exam that you can start looking over. I'm going to do a review where I just go over one of them and I literally go through every problem, remind you of things, but they're all things that we've done before. So I'll pick version 1, version 2, or version 3 to do as a video. You're going to tackle the other 2s on your own. The answers are there, and by all means ask me questions as you go. All right.